Hello there and welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at addition and subtraction of algebraic fractions. We would focus on binomial denominators. In our previous lesson, we looked at how to do the same, but then with monomial denominators. Without much ado, let's quickly look into it. Now, when it comes to adding and subtracting algebraic fractions, when the denominators are binomial, there are key things you need to look for. Do not try to find the LCM until every denominator is fully factorized. You see, so talking of it being factorized, if the denominator is a quadratic or difference of 2 square, you have to break it down. So with that, what I mean is you take note of common factors. Talking of common factors, you might have 2x plus 4. You don't straightforward go and then look for LCM with respect to the other denominator, but rather you'd have to change this. To 2 into bracket x plus 4. That is applying the factorization. If you have terms such as x squared minus 9, you would also need to do something about it. You don't quickly go looking for LCM, but rather you would have to write it as x plus 3. That is applying difference of 2 squares. Then for trinomials, such as x squared plus 5x plus 6, you then have to apply the methods of factorization, which you've already looked at, and then change it toward x plus 2 and then your x plus 3. Until you apply these principles, you don't look for the LCM. If you are able to apply this, you then look for the LCM, which is the product of the highest power of every unique factor found in the denominator. This might not make sense, but then let's solve some examples and you understand it. So for our very first example, we are going to take the denominators. We are going to take that whose denominator is already in its simplest state. That is, we have 2 over x plus 1, then plus 3 over x plus 3. To evaluate this, you realize that this has no factorization to be done, and this also has no factorization. So our LCM will then be a product of these two. Product of these two, we are going to write x plus 1 and then x plus 3. This becomes our denominator, the combined denominator. Now we solve for the numerators. X plus 1, x plus 3 being our denominator, we are going to divide it by x plus 1. And by so doing, this cancels out what you have here. And we have this as the remaining. So this comes to multiply the numerator here. So that we have 2 into bracket x plus 3. Then the same applies to what we have here. So you divide the denominator by all of this. You see, and by so doing, all of this cancels out. It's equivalent here. And you have x plus 1 remaining. That comes to multiply your 3. Then all you need to do is to simplify your numerator. So 2 multiplies x, give us 2x. 2 multiplies 3 to give us 6. 2 multiplies x to also give us 3x. And then 3 multiplies 1 to give us a 3. All over, you have x plus 1 and then x plus 3. Simplifying our numerator, we have 2x plus 3x plus 6, then plus 3. That is, we need to group like terms to be able to simplify. So evaluating, we have 3x plus 2x plus 3x, which gives us a 5x. Then we have 6 plus 3, which also gives us a positive 9. And it's all over x plus 1, and then x plus 3. As simple as that. For this particular example, the denominator needed no further factorization. So let's look at the case where we would actually need to do something to the denominators before we can solve. For this example you have on your screen, we have 5 over x squared minus 1, then minus 2 over x plus 1. If you want to evaluate this, take note. Looking at our denominator, this is a difference of 2 squares. X squared minus 1 can actually be written as x squared minus 1 squared. And this is where the difference of 2 squares plays its role. So difference of 2 squares says you should what? Add the numbers, and then subtract them, and then find the product. So that instead of what we have here, we can rewrite it as 5 over x plus 1, and then x minus 1, then minus 2 over x plus 1. So this becomes the new question we want to work on. Our denominators are x plus 1, x minus 1, that is the product of x plus 1 and then x minus 1, and then x plus 1. Now looking for our LCM, which becomes our lowest common denominator. There's x plus 1 already here, and then there's x plus 1 here as well. So it's like having a 6 and then a 3 and looking for the LCM. In 6, you already have a 2 times 3. And for 3, you have it as it is. What would the LCM be? We are just going to pick the 2 times 3 because 3 is already present here. That is the same idea we need to apply here as well. So x plus 1 is already present in this. Hence, we need to take only the x plus 1, then x minus 1 to be our LCM for both denominators. So that with that, we can now solve. So we have x plus 1, x minus 1, dividing the whole of this over here. And since it is the same thing, it is going to give us 1. That 1 multiplies our numerator so that we have 5 times 1. Minus, for this, we have x plus 1, which would then divide this x plus 1, and we would have x minus 2, x minus 1 remaining. So if x plus 1 divides x plus 1, we then have x minus 2, which will come and multiply the 2. We then simplify our numerator. So 5 times 1 gives us a 5. And we have negative 2 times x, it gives us a negative 2x. Then negative 2 times negative 1, which will give us a positive 2. All over x plus 1, then x minus 1. We would have to regroup to simplify. We have 5 plus 2, that is each term moving with its sign as well. So 5 plus 2 minus 2x all over x plus 1, then x minus 1. Upon further simplification, we have 5 plus 2, which then gives us a 7, then minus 2x over our x plus 1, and then x minus 1, which becomes the final answer of our simplification. Very simple and straightforward. Now, one might ask, what if we have a fraction where both denominators would need factorization? Let's look at such an example. So for this question we have, it says you have to simplify 3 over x squared minus 9, then plus 2 over x squared plus 3x. Now, as you would As you may have realized, the denominator we have here should apply difference of two squares. And then this will then apply the common factor. So for x squared minus 9, we are going to rewrite it as x squared minus 3 squared, which will then be factorized as x minus 3 and then x plus 3. Now for the next one, which is x squared plus 3x, they have x in common. So we have an x then into bracket and x plus 3. That is, we factorizing this. We are going to use this and then this to substitute for what we have here. Hence, we can rewrite our question so that it becomes 3 over, instead of x squared minus 9, we are rewriting it as x minus 3 and then x plus 3. Then plus 2 over, instead of x squared plus 3x, we are going to use x into bracket x plus 3. So how do we get our denominator, our common denominator this time around? If you look at it carefully, you realize that we have x plus 3 and then x plus 3 here already. So for the unique factors, we are actually talking about x minus 3, x plus 3, and then x. These become the unique factors we have in these denominators. So we multiply only the unique factors. Since this is already present here, if we take the whole of this as we did in our previous example, it is going to satisfy. Then all we need to do is to add our x to it, which is what we have here. So our denominator becomes x minus 3, then x plus 3, then times the x. We now work on our numerator. So if we have all of this and we want to divide by this denominator, that is x minus 3, then x plus 3. You realize that this x minus 3, x plus 3 is going to cancel the whole of this, and we'll be left with just our x. So that x multiplies the numerator we have here. So x times 3 times x plus, so we come and then divide also by x into bracket x plus 3. X plus 3 cancels out to the x plus 3. This x cancels out to the x, and this is what we are left with. So the 2 actually multiplies x plus 3. With that, we continue with our simplification. So we have 3 times x, which gives us a 3x. And then 2 times x, which gives us a 2x. And then 3 times 2, which gives us a positive 6. All over our denominator, which is x minus 3, x plus 3, and then x. You can rewrite it in any order. Since it is a product, nothing changes. 3x plus 6x. 3x plus 2x gives us a 5x. We have 5x plus 6 over x minus 3, or let me rewrite it in this order. So x into bracket x minus 3, and then x plus 3, which becomes the final answer to the simplification of all of this. As you realized, we had to factorize both denominators, not just one, but then both. Now we would solve a very last example, and with this, I'm going to add the denominator being a quadratic, so we see how we can apply the rules as well. So for this last one we have, let's take note of how we can solve it. Moreover, you can pause as well, because we've gone through most of these. So to solve this question, as you may have realized, we have the denominators being, one of the denominator being a quadratic. How do we go about it? So we have 1 over x squared plus 5x, then plus 6, plus 1 over x plus 2. Now take note that we would have to factorize this. So we have x squared plus 5x plus 6. Factorizing it, we've gone over how to factorize these expressions. We have 1 here, and then the 1 multiplies the 6 to give us 6. The factor pairs of 6, which when added gives us 5, is 3 and then 2. Hence, we have x squared plus 2x plus 3x plus 6. So the next step says we should group and then factorize. Grouping in pairs, we have x squared plus 2x and then 3x plus 6 also in one bracket. Factorizing, we know x squared and then 2x have the highest common factor of x. So that x comes out, and x times what gives us x squared, that is an x. X times what gives us a positive 2x, that is a 2. For this as well, the numbers have a 3 as their common factor, then x plus 2 comes in. Since these two brackets are the same, we can rewrite it as x plus 2 and then x plus 3. That is the x plus 3 from the coefficient of the bracket. Instead of writing all of this, we are just going to substitute it with this. Hence, we have 1 over x squared, 1 over x plus 2, and then x plus 3, plus your 1 over x plus 2. We can now solve. There is x plus 2 here as well. So because of that, following the previous examples, we can take the whole of this as our LCM. So since we have x plus 2 and then x plus 2 here, we can pick the whole of this, which is x plus 2 and then x plus 3 as our common denominator. So that x plus 2, x plus 3 divides itself once. That 1 now multiplies our numerator so that we have 1 times 1, then plus, there's x plus 2 here. That cancels out this x plus 2 to give us x plus 3 as our remainder. And that now multiplies your 1. We have plus 1 times x plus 3. Simplifying our numerator, we have 1 times 1, which gives us 1. Then plus 1 times x gives us an x. And then 1 times 3 also gives us a 3. So that we have x plus 3 all over x plus 2, then x plus 3. If you are to group like terms of the numerator, we have x plus 3 plus 1 all over x plus 2 in one bracket, then x plus 3 also in another bracket. X, then 3 plus 1 gives us a 4 all over x plus 2, then x plus 3. This becomes our final answer when we evaluate what we have over here. We are going to end this lesson here, and I'll give you some exercises so you try on your own. So here are some examples you can try on your own. There are 5 in all, and it just applies all that we have done in this lesson. If there's any issue of concern, you can always let me know at the comment section, and I'll address that. It is Hub Beyond Numbers, and if you have not subscribed and you wish to, so that anytime I release a video, you'll be notified, you can do that as you wish. Stay blessed and bye for now.